This is a simple approach to dividing a space in perspective that doesn't really require the learning of new techniques, and it uses a technique that is probably one of the most common, which is doubling or halving, using the x diagonals. So this is a square in 2-point perspective. The vanishing points are equidistant, resulting in a 45-degree square. Here are diagonal lines dividing the square into thirds. These diagonal lines dividing the square into thirds will be used to check the accuracy of this square divided into thirds by simply doubling some spaces. So this diagonal line is simply multiplying this half of the square, resulting in 3 halves, with the resulting rectangle being cut by a diagonal, where that diagonal cuts one of these halves going towards the left vanishing point. These lines toward the right vanishing point can be drawn, and you can see that where these new lines heading towards the right vanishing point intersect the 45-degree diagonals of the square, also intersect the diagonal lines that give us the points for our geometric thirds. Of course, this is because we have 3 equal spaces in perspective that are dividing this rectangle. And since these divisions have been turned perpendicularly to the right vanishing point, this original square is also divided into thirds going in this direction. Using one of the original diagonals, these thirds can be taken towards this vanishing point, cutting transverse or perpendicular to the original divisions. This would be the resulting square, and here's the square without the original geometric approach to dividing the square into thirds, which is completely unnecessary and was only used as a proof. So as long as you're familiar with using the X method in perspective, you can create as many equal spaces. It could be the full square, half, quarter, any division that's even and multiplied into perspective on either side, and then those divisions can be transferred 90 degrees to the other vanishing point, or any arbitrary space that is multiplied. In perspective, a little bit of logic goes a long way.